Alright, in this video I want to show you how to solve systems of equations using, we already talked about graphing. This is a new method called substitution. And the easiest way to think of substitution is you're going to solve for either x or y so that your intermediate step is going to say x equals something or y equals something. And I'll show you, it'll make more sense when we actually do the problem. And then you take whatever that is and you take this and substitute it into the other equation. Okay, so let's look at number one. Which one would be easier to solve for? And in this case, it's always easier to solve for the thing that has a coefficient of 1. So you can see right there, that x right there, that's a 1x. So it's easiest to solve for x right there, not for y. Okay, so how will we solve for x? Well, we want to get x by itself. Right now, x is having 6y subtracted from it. So we can solve for x. We can get it by itself by doing the opposite of minus 6y, which is plus 6y. Okay, so we have this. We have x equals negative 4 plus 6y, or we could just say 6y minus 4. That's what x equals. Here's why this is called substitution. Now that I know that x is equal to this, I can go up here, and wherever I see an x, I can plug that in right there. And if that doesn't make sense to you, here's a kind of a more everyday example that you can think about. This would be a strange way to say it, but we could say that July is equal to the month after June. I'll abbreviate that MAJ, month after June. We could also say that July is equal to the month before August, MBA, month before August. My question for you is, could you make a third sentence that has month after June in it and that has month before August in it, but that does not have July in it? So think about that for a sec. Is there a third sentence that has this month after June and month before August, somehow connects those two but doesn't have July in it? And the answer is yes. You could basically, since July equals month before August, wherever I see a July, I can just substitute month before August. And think about this, the month before August is equal to the month after June. Okay, that's definitely true. So let's try that up here. Let's take the x, and we know that x is equivalent to 6y minus 4. So that means wherever I see an x, I'm going to plug in 6y minus 4. And now we can solve this right here. So we will distribute the 3. We come down here so we have more room. We'll distribute the 3, so we'll get 18y minus 3 times minus 4 is minus 12. Okay, now we can combine 18y and 7y. 18y minus 7y is 11y. Okay, and then let's add 12 to both sides. And let's see, did we do something? Oh no, didn't. I thought we made a mistake there, but I think everything's right. So 11y equals negative 1 plus 12 is 11, so we can solve for y by dividing by 11. That means y is equal to 1. Okay, here's the thing. In order to solve this completely, you need to solve not only for y, but also for x. So solving for x is easier. How do we solve for x? We just plug in our y value. In this case, we'll plug in y equals 1. Does it matter where you plug it in? The answer is no. You could either pick this one or this one to solve for x. Let's just pick the second one. This might be slightly easier, but it doesn't matter. You could get the first one too. So I'm taking this y and I'm substituting a 1 in there because we just found that y equals 1, y equals positive 1. So 6 times 1 is 6, and then if we add 6 to both sides, we would come up with negative 4 plus 6, x equals 2. So here's how a lot of times they'll write the solution. They'll write it like a coordinate pair. So x comma y would be x equals 2 and y equals 1. So there's our answer. We could always check, if we really wanted to be sure, we could check by plugging in x here and y here and doing the same here and here. You want to be super sure. It's a little bit hard to get these problems wrong, because even if you do get it wrong, you can always check by plugging it back in. All right, let's do 2 more. So I want you to pause the video and try this one and then come back when you're ready to look at it. So number 2, give that one a try. So again, we want to solve for either x or y. Let's switch it up this time. Let's solve for y. So right here we can solve for y by getting rid of the minus x by adding x to both sides. So we'll get y equals x minus 6. That means in this equation, wherever I see a y, I can now substitute this right here. I can substitute x minus 6. Okay, we have a minus in front of a parenthesis, so that means I have to distribute the minus, so x minus x, and then minus negative 6 becomes plus 6. Okay, x minus x, those cancel, we're left with 0, so 0 plus 6 is 6. And now we have a problem. 6 equals 8. Well, how did that happen? Okay, here's the idea. With substitution, you might remember this from the graphing example. Okay, I'll just show you kind of a visual. You could have three possibilities here when you're graphing two lines. You could have three possibilities. You could have two lines. I'm just going to draw a couple lines here. You could have two lines that meet in one point, like on picture A, and that's like this example. They meet at the point 2 comma 1. Okay, so this has one solution. You could have two lines that are actually like the exact same line. So I don't know if you can see that orange one on top of the green. That actually has an infinite number of solutions because the lines meet in every single point. And then you could have a case like what we just got here, two lines that never meet, no solutions. How do you know? From a graph, it's easy to tell. This is clear that those lines are never going to meet, they're parallel. How do you know from an equation like number 2? How would you know that this has no solution? And you can ask yourself this way, okay? How many x and y values make it true that 6 equals 8? And the answer is this never happens. It's never true that 6 equals 8. So there is no solution. There's no x and there's no y that make that true. Okay, no x and no y make that true. Therefore, there are no solutions. What would it look like if there were infinite solutions? If you did that same problem and you wound up with an answer like this. You got 6 equals 6 or 8 equals 8 or something that's obviously true. If it's obviously true, if it's always true, that means there are infinite solutions. So I hope that distinction makes sense to you. If it's never true for any x and y, there's no solutions. If it's always true, if 6 is always equal to 6, 8 is always equal to 8, you'd have infinite solutions. Last one I want to show you is what if x and y don't have a coefficient of 1. So in both of those examples we had 1x and 1y. In this case we don't. Okay, so here's what you can do. You basically pick a variable, and I think the negative y would be easiest here. And we'll do the same thing, we'll just have to make one extra step. So we'll add 8x to both sides, we'll have negative y equals 8x plus 12. We need it to be y equals, not negative y equals, and the easiest way to do that is just divide by negative 1. Okay, if that had been 10y, you would divide by 10. If that were a million y, you would divide by a million. So the idea is you do the same thing, you just have to solve for y with one extra step in this case. So this thing becomes y. 8x divided by negative 1 is negative 8x. 12 divided by a negative 1 is negative 12. Now we've solved for y. Now we can come over to this other equation right here. And wherever I see a y, I'm going to substitute this in right here. Negative 8x minus 12. Okay, now let's solve this. So 8x plus 3 times negative 8x is negative 24x. 3 times negative 12 is negative 36. Okay, 8x plus negative 24x is negative 16x. We'll add the 36 to both sides. Negative 20 plus 36 is 16. And then if we divide by negative 16, we would get x equals negative 1. Okay, let's solve for y now. So we'll solve for y, we'll plug in, again, it doesn't matter where we plug it in. Let's just plug it into this top one right here. So negative 8x becomes negative 8 times, we know that x is negative 1, so that's why we're plugging in negative 1. Negative 8 times negative 1 is 8, and then if we subtract 8 from both sides, we would get negative y equals to 4. If we divide both sides by negative 1, we would get y equals negative 4. So our final answer should be x equals negative 1, y equals negative 4. And that's how you solve using substitution.